In this class, let us study about bases and exponents. Suppose you have a non-negative integer a, and a is multiplied by itself repeatedly for n number of times. Then we can express it in an exponential form as a raised to n. Here a is called the base, that is, the number which is repeatedly being multiplied is called the base, and this number, the number of times it is multiplied, it is called the exponent or the index, or it is said to be the power of the base a. Now for example, consider this number 5, which is say being multiplied 5 times or say 4 times with itself. We are multiplying it 4 times. So we can write this exponentially as 5 raised to 4. Here 5 is the base and 4 is the exponent or the index. Now let us see some simple examples. What would be 5 raised to 1? A number multiplied by itself by just once. So it will just be 5. What would be 5 raised to 2? That would be 5 into 5, which is 25. And now this is also called 5 square. You can say it as 5 raised to 2 or 5 square. Similarly, what would be 5 raised to 3? That would be 5 multiplied by itself 3 times. That is 125. Now this is also called 5 cube. This is 5 raised to 1, this is 5 square, and this is 5 cube. And 5 raised to 4 would be what? It would be 5 multiplied by itself 4 times, which would be 25 into 25, it would be 625. Now let's move on to some basic rules regarding the exponents. The first one we have is the zero exponent law. Any number raised to 0 is 1. 5 raised to 0 is 1. 2 raised to 0 is 1. Any number raised to 0 is 1. The second law we have is called the product of powers law. That means a raised to m into a raised to n is equal to a raised to m plus n. We will take an example and see what this means. Suppose you have 2 raised to 3 into 2 raised to 4. According to this law, this is the same as 2 raised to 3 plus 4, which is 2 raised to 7. Now it's this is quite evident, right? So why? Let us see. 2 raised to 3 or 2 cube is 2 repeatedly being multiplied 3 times, and 2 being multiplied by itself for 4 times. So now how much is this? You can see that this is exactly 2 raised to 7. So it is quite an evident one. So let us see one more example. What would be this? This would be 5 raised to 5. Now be very careful, don't make this mistake. I often see people getting confused with these two expressions. See, these two expressions are not same. Here we have the plus sign. What does the rule say? It is not the sum of the powers, it is the product of the powers. There is no rule regarding the sum of the powers. You just have to do it the usual way. What is 5 square? 5 square would be 5 into 5, which is 25. And what is 5 cube? That is 5 multiplied with itself 3 times. That would be 25 into 5, that would be 125. Or in other words, this would be 150. But that is not the same as 5 raised to 5. So 5 raised to 5 would be so as you can see, 5 square into 5 cube is a different answer, and 5 square plus 5 cube gives a different answer. These are two different things. So please don't get confused with this. This talks about the product of two numbers which have the same base but different exponents. And now we come to the third rule, is the power of product rule. If we have AB, a number which can be expressed as the product of two numbers, this raised to m is the same as A raised to m into B raised to m. Now, what does that mean? Suppose you have 15 square. But what is 15? 15 is 3 into 5. That means this is the same as 3 square into 5 square. That is what this law states. Similarly, say 18 cube. What is 18? 18 is 2 into 9. So 18 cube is the same as 2 cube into 9 cube. Also 18 is what? It is 3 into 6. So you can also write 18 cube as 3 cube into 6 cube. And you can also write it as 3 cube into 3 cube into 2 cube. Why is that? Because 18 is 3 into 3 into 2. So you can write it in any of these ways. Please note that this works both ways. You can start from here also. Suppose you have 2 raised to 3 into 5 raised to 3. So what do you have here? Different bases but same exponent. That means it can be written as 10 cube. Now consider, what does this one say here? This rule say here, that is the same base but different exponent. Do you see how these two rules differ? I will give you one more example. Here you have the product of two numbers. What do you notice here? They have different bases, but then their powers are the same. Then what do you see? What do? You multiply the bases and write it as 20 raised to 4. That is what this rule was about. Now you have another number, say 10 raised to 3 into 10 raised to 8. So you have same base but different powers. Then you add the powers. Then you have 10 raised to 3 plus 8, which is 10 raised to 11. And the fourth law we have here is called the power of power. You can also call it exponent of exponent. The word exponent, index, power, they all mean the same thing. 0 exponent, 0 power, all of them mean the same thing. So what does this law say? You have a raised to m, the whole raised to n. You have two powers. Then that is equal to a raised to m into n. So let us see with an example how that works. 2 cube, the whole raised to 4. This is the same as 2 raised to 12. That again, the answer is like evident. How do you do this? What is 2 cube? 2 cube is 2 multiplied 3 times. The whole raised to 4. What does that mean? Any number raised to 4 means what? That number multiplied with itself 4 times. So this number is being multiplied with itself 4 times. So naturally this would be 2 raised to 12. It makes sense, right? So that is this law. Similarly, what would be 5 raised to 4, the whole raised to 5? That would be 5 raised to 20. And what would be 3 raised to 7, the whole raised to 4? That would be 3 raised to 28. Now let us go to the fifth rule. Now we move on to the fifth rule, which is called the quotient of power rule. So what does that state? You have two numbers, the quotient of which is two numbers, where the bases are same but their powers or their exponents are different. Then a raised to m divided by a raised to n is equal to a raised to m minus n. So how does that help us? Suppose you have to divide 15 raised to 8 by 15 raised to say 6. Then instead of here multiplying 15 8 times and then multiplying 15 6 times and then finding the quotient, the easy way would be this. This is the same as 15 square, and that answer would be this. So this makes your life easy. Now we come to the sixth rule. Now this is our sixth law. What does it say? You have a quotient, say a divided by b. A divided b raised to m is the same as a raised to m by b raised to m. And how do we apply this? Suppose we have 15 divided by 14, the whole raised to say 3. This is the same as 15 cube by 14 cube. And now how does this help us? Suppose you have to suppose you have to divide say 15 raised to 8 by 5 raised to 8. So instead of multiplying 15 like 8 times and then 5 8 times and then finding the quotient, you can do this. You can take 15 by 5 raised to 8. And why did you take this? Because see, the exponent is same. When the exponent is same, you can take the quotient of both these numbers together and take it to the power of 8. So this is the same as 3 raised to 8. See, this makes your life easy. Let us see one more example. Say 16 raised to 10 by 8 raised to 10. This is the same as 16 by 8 raised to 10. Why did you do this? Because the exponent is same. This is the same as 2 raised to 10. The seventh law is what happens if your base is negative. That is, how do we deal with a negative base? If you remember, I started off the lesson by saying that a is a non-negative integer. But then non-negatives are not the only ones which are integers, right? You have 0 and you have negative integers. So what happens? 0, it would be easy, right? 0 raised to any number would be just 0 itself. So 0 is not a problem. What if your base is a negative integer? Then there are two cases that are possible. One, if m is even, and the second case, if m is odd. So if m is even, then this number is the same as a raised to m. But if m is odd, then this number, this expression is the same as minus a raised to m. Now what does that mean? Take minus 2 for example. Minus 2 raised to 2. That is the square of minus 2. That would be minus 2 into minus 2, which is plus 4. What is plus 4? It is the same as 2 square. So why is that? Because the negative sign multiplied an even number of times will be positive. Negative, if multiplied even number of times, it will become positive. But negative sign multiplied an odd number of times would be minus. So now what about minus 2 cube raised to 3? That is minus 2 multiplied 3 times. 3 negative signs, the answer will also have a minus sign. It is the same as 2 cube. Right? It is the same as minus 2 cube. Another question. Minus 8 raised to 4. Now 4 is a even number. So minus 8 raised to 4 is the same as 8 raised to 4. You can just forget about the minus sign. But then minus 8 raised to 5. Minus sign multiplied 5 times will give again, it will give the minus sign. So the answer will be the same, but you will have a minus to the answer. So that's what this law states. Look at the exponent. If the exponent is even, get rid of the negative sign. You don't need that. Exponent is even, get rid of the negative sign. But if the exponent is odd, the answer will have a negative sign. There, an odd exponent, the answer will have a negative sign. Now what was this law about? This was about a negative base. But what if the exponent is negative? That is what we will see next. Now this 8th law is about negative power. That is, the base, it's positive, but it has a negative power. Now what was the earlier one that we learned? It was about a negative base. And then we learned that it depends on whether m is positive or negative. But this one is about the negative power. And before we go to that, let us just brush up our reciprocals. What is the reciprocal of 5 by 6? It is 6 by 5, right? The reciprocal of 5 by 6 is 6 by 5, and the reciprocal of 6 by 5 is 5 by 6. Similarly, if you have 4 by 3, what is its reciprocal? It is 3 by 4, which means the denominator becomes the numerator becomes the denominator, right? So these are reciprocals of each other. What about 4? What is the reciprocal of 4? This does not have any denominator. That means its denominator is 1. So the reciprocal of 4 is 1 by 4. Similarly, what is the reciprocal of 1 by 4? It is 4. So these two are the reciprocals of each other. That is what we need here. If you have a negative power, a negative exponent, we need to get rid of it, right? We don't want negativity in our life. So how do we get rid of this negative power? By taking the reciprocal of the base. For a, what is its reciprocal? Its reciprocal will be 1 by a, and it will have a positive power. There, this is what it means. That means if you have 2 raised to minus 4, how do we get rid of this negativity, this negative power? We take the reciprocal of 2 with the positive power. This is when you have an integer. What about 5 by 3 raised to minus 7? Now how do we get rid of this minus sign? Find its reciprocal. 3 by 5, and this will become positive. We have made the negative into the positive. Once again, so what about this? Now, the negative sign here is in the denominator. How do we get rid of it? Find the reciprocal of 1 by 2. What is the reciprocal of 1 by 2? It is 2. 2 raised to 7. So wherever you see a number, a base with a negative power, how do you make that negative power into positive? You just take the reciprocal of the base. Now we will see an example. Say 5 raised to minus 3 into 2 raised to 8 by 5 raised to say 4 into 2 raised to minus 10. Now, what do we do with this? In this, we will learn many of the laws that we have learned earlier also. The product of the power of the product. We will use some of those laws also. So now what do you have here? 5 raised to minus 3, and in the denominator you have 5 raised to 4. How do we get rid of this? This we will write as it is. This is a positive power, right? So we don't have to worry about it. How do we change this? How do we make this into a positive power? Bring it down. So you already have 5 raised to 4 here. Bring this down. Then you have 5 cube. Now you have 2 raised to minus 10 here. How do you make this minus into a positive? Take it to the numerator, then it will become positive. There. Then you have same base, different powers, add both of them. Again, same base, different powers, add both of them, and this is your answer. So, whenever you want to make a negative power into positive, bring it from the denominator to the numerator or from the numerator to the denominator. Now there is another rule which is not actually for beginners. I would just mention it. It is, what does a raised to 1 by m mean? What is 16 raised to 1 by 2? We know what is 16 raised to 2. It is 16 into 16, right? But then 16 raised to 1 by 2 means square root of 16. That would be 16 is 4 into 4. 4 multiplied 2 times gives 16. So this is actually equal to 4. Again, what does say 27 raised to 1 by 3 mean? We know what 27 raised to 3 means. It means 27 multiplied 3 times. But then 27 raised to 1 by 3 is actually the cube root of 27. This is not for beginners. You will study it in the later classes, but I just mentioned it. Now let us go on to some question answers. So product of two numbers is 2 by 5 raised to minus 3. One of them is 5 by 4 raised to minus 2. So let that number be x. So one number is 5 by 4 raised to minus 2 multiplied with x should give. So we need to find what this x is. So how do we open the bracket? All we have to do is find its reciprocal. That will change this exponent into negative. Actually, I don't think we have to do that. We will just continue the usual way. This is 5 raised to minus 2 by 4 raised to minus 2 into x. This is the same as 2 raised to minus 3 by 5 raised to minus 3. Now what if we cross multiply? We will just leave x in one here, because as it is an algebraic expression, we just need to isolate x in one side and take all the numbers to the other side. So what do you have here already? You have this here already. When you cross multiply, what is in the denominator goes up. So this would be 4 raised to minus 2. And what is in the numerator? That comes down into 5 raised to minus 2. But then, do you see the difference in the base? This is 2 and this is 4. So how do you make 4 into 2? This is 2 square raised to minus 2. That is equal to 5 raised to same base, different exponents, and it has a multiplication sign in between. So that means this is like this. So that would be 2 raised to minus 3 minus 4. Why? 2 into minus 2, because we know that a raised to m, the whole raised to n, is equal to a raised to m into n. So 2 into minus 2 would give you minus 4. That would be 5 raised to minus 5. So the answer will be 2 raised to minus 7 by 5 raised to minus 5. We can just get rid of these negative signs by changing them. So 5 raised to 5 by 2 raised to 7 is the answer you need. So we have to find x if 18 raised to 10 is equal to 4 raised to 5 into 3 raised to x. So whenever the exponent is missing, try to equate the bases. Make the bases same and then you can equate the exponents. Why is that? If suppose 2 raised to 3 is equal to 2 raised to x, what will this mean? The only option you will have is that x has to be equal to 3. So that is what we are going to do here. You see the different bases here, make all of that same, then you can equate the exponents. What is 18? 18 is 2 into 3 into 3, that is the whole raised to 10. And what about 4? 4 is 2 raised to 2, now the whole raised to 5. This is what? 2 into 3 square raised to 10. This would be 2 into 5, which would be 10. Again opening the brackets. Now you see what's happening here. There is the base 2 which has the same exponent. 2 raised to 10, 2 raised to 10. So we are fine with that. What about the 3 here? 3 raised to 20. This will naturally mean 3 raised to 20 is equal to 3 raised to x. That would mean x is equal to 20. Let's go on to the next question. Now what does this question tell you? You have the same base, different exponents and a divided by sign in the middle. That means this is the same as 8 raised to 3 minus 6. But then you see the difference in the base here. Here the base is 8, here the base is 1 by 8. So I'll first write the answer here. Raised to minus 3. 6 minus 3 it will be 3. So 3 minus 6 would be minus 3. There. See, you have different bases. How do you make this the same base? How do you take this? All you have to do is take its reciprocal. But then when you take its reciprocal, the sign of the exponent changes. What does that mean? Now let's do simplification questions. In simplification questions, you see the big numbers, reduce them into their factors. That will make it easier. Now 3 raised to minus 5, there is nothing you can do to 3. 3 is just 3 into 1. But then what about 10? 10 is 2 into 5. The whole raised to minus 5. Do not forget to put the brackets. And what is 125? It is 5 into 5 into 5, which is 5 cubed. And here you have 5 raised to minus 7 and 6 is what? 2 into 3. So this would be 3 raised to minus 5 into 2 raised to minus 5 into 5 raised to minus 5 into 5 cubed by 5 raised to minus 7 into 2 raised to minus 5 into 3 raised to minus 5. Now wherever you see 3, or join all of them together, bring all of them together. Here you have a minus 5, but then when this thing goes up, the sign will change and it will become 3 raised to 5. Then here you have 2 raised to minus 5, but when this goes up, it will become 2 raised to 5. Here it is minus, when it goes to the numerator, it will become minus 5, plus 5. Then you have a 5 here. You have already 5 raised to minus 5, 5 raised to 3, and here it is 5 raised to minus 7. When it goes up, it will become 5 raised to plus 7. That is 3 raised to minus 5 plus 5. Why is that? Same base, different exponents and a multiplication sign in between. And similarly 2 raised to minus 5 plus 5. Why? Same base, different exponents. And similarly, so that would be 3 raised to 0. Any number raised to 0 is 1. Again 2 raised to 0. Again 1. Any number raised to 0 is 1. And 5 raised to, this would be 10 minus 5, which would be 5 raised to 5. 5 raised to 5 would be 25 into 25 into 5. That would be 625 into 5. That would be 25. It is 5 square. A raised to minus 4. Then 5 raised to minus 3. Do not leave the 10 as it is. It is actually 2 into 5 into a raised to minus 8. So what do we do? Bring all the 5's together into, this is a 5 raised to minus 3. When it goes up, it will become 5 raised to plus 3. Here it is 5. Just 5 means 5 raised to 1. And when it goes up, it will become 5 raised to minus 1. and a raised to minus 4, and this is a raised to minus 8. When it goes up, it will become a raised to 8. The whole thing divided by 2. There is just one 2 here. You don't have any other 2's. So just write divided by 2. That would be same base, different exponents, and you have a multiplication sign. 5 raised to 2 plus 3 minus 1 into a raised to minus 4 plus 8. The whole divided by 2. That would be 5 raised to 4, a raised to 4 by 2. 5 raised to 4 would be 25 into 25, which is 625. A raised to 4 by 2. Now we come to the end of this lesson. Let us quickly recap what we learned so far. How do exponents help us? It helps us to write extremely big numbers or extremely small numbers in an exponential way. How does we achieve that? See, for example, suppose you have something like this, an extremely big number. So you can write, what is this? This is actually 7 into, so that means you can write it as 7 into 10 raised to how many zeros? 1, 2, 3, 4, 5, 6, 7. See, you can write this an extremely big number, but you have written it in a small way. And similarly, suppose you have something like this. This also you can write it as, say, see. And what if you have a very small number like, say, 0.0004? What do you do with this? What is this actually? This is 4 divided by 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That means 4 divided by 10 raised to 5. That means 4 into 10 raised to minus 5. See, it was a very small number, but you have written it in an exponential form. And similarly, it makes your multiplications easy. How? Let us see. For example, you have 2 raised to 3 into, say, 5 raised to 4. What have we learnt? If the bases are different and the exponents are same, you can group them together, right? See, a raised to m into b raised to m is equal to ab raised to m. So the exponents are different and the bases are also different. So what do we do? What if I make this exponent equal? What if I make them the same exponent? 2 raised to 3 into 5 raised to 3 into 5. That makes sense, doesn't it? See, 5 raised to 4 is the same as 5 raised to 3 into 5. So now what can you do? Now you can group them together and write it like this. So this is 10 raised to 3 into 5, which means 5 followed by 3 zeros. Isn't that easy? Otherwise, what would you have done? 2 raised to 3 would be 4 into 2, 8. 5 raised to 4 would have been 625, and then you would have to do the whole multiplication. But then this way, it makes it easy. Similarly, I will show you one more example. Here, we had different bases, right? See something like this. 2 raised to 5 by, say, 4 raised to 4. Now, you have to do 20 into 20 into 25 times and 4 into 4 into 4 times. Instead of that, can we apply this? A by B, the whole raised to m is equal to a raised to m by b raised to m. But then for that you need the same exponent. But see here, different exponents. So what if I make it the same exponent? What if I write it like this? There. So now you have the same exponent. Now bring them both together. And that would be cancel 5. 5 raised to 4 into 20. So what exponents does is that it enables you to write extremely large numbers, extremely small numbers, makes your multiplication, your division all easy. And what do you have to do? Just make sure if your exponents are same or your base is same, and if it is not same, you make it same. So that is all for today. Till we meet you again. Assalamu alaikum.